5.4, analyzing graphs of polynomial functions. So we're just going to analyze graphs, so we're going to start off by looking at domain and range. So domain is the x values, range is the y values. There's my x. So I'm going to go, how far left does your graph go? Start from the left side here. As far as I see, it's an arrow. So we consider that negative infinity. As far as the right, I see it's an arrow again. So it's positive infinity. Now the range, it's the y, you go low to high. Lowest I see is -5. That's the lowest it goes. And the highest I see is an arrow in both cases. So that's infinity. It's going on forever and ever. Just like that. You go negative infinity and -5 to infinity. Notice -5 has a bracket because it's a close. It's just a point right there. So it's a close set. Infinity is always a parenthesis because it's open. It goes on forever. Right, so this is close and open. So that's a open set. Next one. Domain is the x again. So right, what's farthest left I see? That's from here to here. So it looks like from -2 to 2. Keep in mind they're both closed, it's just part of a line, so it's both closed. My range goes from here to here, 1 to 5. Again, both closed, so you don't see any arrows. Next one, domain. Well, farthest left I see is an arrow. Farthest right I see is an arrow. So negative infinity, positive infinity. Range, lowest I see is what? 1, 2, 3. -3 it looks like. And the highest I see is an arrow. So infinity. Next one, domain. So domain's x, right? So farthest left I see is right here. So 0. Farthest right I see is an arrow. 0 to always infinity. Range, what's the lowest I see? Lowest I see is right here, but notice it's an arrow. It keeps on going down. So negative infinity is my lowest. The highest I see is similar. I see an arrow as the highest. So infinity. Next one, domain, left to right. So farthest left I see is an arrow. Farthest right I see is an arrow. So negative infinity, positive infinity. Range, lowest I see is right here, -3. Highest I see is an arrow. Arrow always wins. That's infinity. So -3 to infinity. Domain, well, domain here, farthest left is an arrow. So negative infinity. Farthest right is an arrow. Positive infinity. With the range, lowest I see is an arrow. Remember, this is low, but this is lower. Arrow always goes on forever. Arrow always wins. Negative infinity. And then, same thing up here. Highest I see is an arrow. Positive infinity. Now the next one, dynamic compact distance can be modeled by a quadratic function 0.4x to the 4 minus blah blah blah. Graph the function from 0 to 10. I still don't have my computer this week, so I can't graph it on here. It is x to the 4th. I believe it kind of looks like this. That's not very good, actually. It might look like this. Something to this effect. So, I apologize. I don't have my calculator with me. Describe the trinity points of graph function. So, trinity points is just a maximum. So, if I was doing this, there'd be a max around 1. And a min. That's all turning points are max and mins at like 5 and 4, 350. Again, mines are probably totally off. I don't have a calculator with me right now to show. Continue the graph of x equals 12, 11, 12. What trend to the compact this does the graph suggest? That it looks like it's going to go on forever. Keep on increasing. Is it reasonable the trend will continue indefinitely? This is generally a no for this answer. It's generally no. So in this case, no, because new technology like MP3 players, they didn't see iTunes coming. So no, CDs won't be selling forever, going up in sales forever. Next one. This one they give us some information they want us to draw. So you have to graph the polynomial function with the following characteristics. It's an odd function, so what does that mean? An odd function means it's open like this, or like this, or like this and like that. with zeros. What are zeros? So they're just x-intercepts. So if I was going to draw this thing, again, it's just a sketch, not perfect. First thing I know is that I have zeros at -5, -3, 0, 2, and 4. Right, that's what this thing tells me. And then I know it should be an odd function. So if I start, let's say it doesn't matter which one, you can start up here if you want. It has to end on the opposite side because it's odd. So now you just kind of go through each one once. Go through it, go through it, go through it, go through it, and go through it. Right, I'm just following the graph. That's one example. There's actually just multiple examples, but that's the one I did. Next one, same idea. An even function, so it's gonna be like this, or like this. 0, 0. So again, I know what my zeros are. I have 5, 3, 1, and -2. Other than that, I just know it's even. So again, you want to start on top, we'll start on top. Just go through it. Once you go through it, you're on the other side, then you have to go through this one. So just turn and go through that one. You're on the other side now, so turn and go through that one. Cross it, and then turn and go through that one. And look at that, even function. A 4-degree function with a 0 at -3 and a maximum at x equals 2 and a minimum at x equals -1. So let's put all that into context. xy. I have a 0 at -3, so that's my only x-intercept. I have a max at 2, so 1, 2 is my max. Put a max. If you actually anywhere, but put it like that. I mean, anywhere up and down. My min's at -1, so that -1 is below min. So something to that effect. That's all, and it's a 4-degree function. So this lets me know it's even. So it should look like this, or like this. Based on what I have here, it looks like I'm starting up there, and then kind of go through this, cross somewhere, go through this, but that makes me turn and go down. So it's in that effect. And actually, probably even a better one, because this one says that, I mean, it doesn't preclude having more zeros, but if I just want one that only has 1 0, I could do it like this. So I go through here, I have a min at -2, -1, and I have a max at 2, but I can't go across it, so I just gotta have my max right here. That's an even better one. Because I only have 1 0 instead of this one has 3 zeros, and I have a min at 1 and a max at 2. Next one, estimate the x1 of every turning point. So I got to estimate the turning points. Estimate the x1 of every 0. Determine the smallest possible degree of the function. We'll talk about that, and then D, find the domain range. So every turning point. So let me see my maxes. I'll do relative max, and we'll do relative min or local. So where my relative max is at? Here, here. That's it. So it's a little hard to see the xy. So to right there's xy. So -1, 2, 3. So I get -1 and I get -3.5. Relative mins are right here. Right here. So at -2.5 and that's the 2.5. B is to find x coordinate of every 0. So the zeros are right here, here, and we're just an estimate. We'll say -2, 0, and about 3. Let's use an estimation. C, determine the smallest possible degree. So smallest possible degree, it's a little formula, which is turning points plus 1. So look how many turning points we have. We have 1 turning point, 2 turning points, 3, 4. So 4 plus 1 gets me 5th. Smallest possible degree this guy can have is x to the 5th. Which makes sense. Look at that. It's an odd function. Look at my graph. It's an odd graph. So it fits a narrative. Next, domain range. Domain is my x. Range is my y. Farthest x I see is an arrow, -infinity. Farthest y I see is an arrow, +infinity. Here's a little hint. If it's an odd function, it's going to be the same thing for the range. Lowest I see is an arrow, negative infinity. Highest I see is an arrow, positive infinity. Let's do that again a couple more times, apparently. I didn't realize we need two more times. A, B, C, D. So I gotta do relative min, relative max. And this one has two relative mins. We'll just estimate it. Again, it's hard for me to see the XY axis. There we go. So we'll say like -2 for this one, and we'll say like 2 for that one. It's more like 2.5 and 1.5. Relative max is right here, 0.5, -0.5 actually. Those are annoying. B is the row 0, so let's see, route there, 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 and there. That one I'll just straight out estimate. 1, 2, 3, 4. -1, 0, and 3. Smallest degree. Remember, smallest degree is turning points plus 1. And how many turning points do we have? We have 1 turning point, 2 turning points, 3 turning points. So it's going to be 3 plus 1, which is 4, or x to the 4th. Which again, makes sense, because look at it's an even function. Right? Notice how things are going up. So it's an even function, x to the 4th makes total sense. Domain range. Domain, farthest left is negative infinity. Farthest right is infinity. Range, my lowest is 1, 2, 3, -3, bracket. My highest is infinity. And then the last one here, oh, since it's suck. A, B, C, D. So again, relative min. We'll say local min. It's the same thing, just so we get a different feel for it. Local min and local max. My local min is going to be at, let's see, here, here, and here. Oh man, I draw a line again. It's so hard to see. So let's say -2 and -3.5. That looks like a +1. My local maxes are here, here, and that's it. So x equals -1 and -2.5-ish. My zeros would be there's like 4 of them, 5, 6 of them. I'm gonna say it's 6 zeros. I'm not gonna say where there are, there's too many. C is, remember, it's smallest degree. That's what C is. What's the smallest degree? And that's turning points plus 1. Well, how many turn points do we have? Let's count. It's a lot, I think. 1, 2, 3, 4, 5. So 5 plus 1, which is 6. So x to the 6. Which makes sense. Again, notice it's an even function. So it does make sense. And then D is my last, is domain range. Domain, look at the farthest left, -infinity, farthest right, infinity for the arrows. My range was my lowest is right here. 1, 2, 3, 4, 5. And my highest is arrow, so infinity. That's the lesson.